Jai Hind dear students, I am Dr. Preeti Mittal and today we are going to have a look at the questions given in the NCERT book from gravitation chapter. Okay, so without wasting any time, let's start with that. Question number 1. How does the force of gravitation between two objects change when the distance between them is reduced to half? So it's a question based on gravitational force of attraction. So first, let us write down the formula required to do this question at one corner of the board. F is equals to capital G m1 m2 upon distance square. I hope you remember the formula. So it's said that when the distance between them is reduced to half, what will be the force of attraction? Question number 1. So original force of attraction is equals to capital G m1 m2 upon distance square. Now new distance, I'm representing it by d dash. New distance is d upon 2, it reduced to half. So what will be the new force? I'm representing that with F dash. F dash is equals to capital G m1 m2 upon d by 2 whole square because new distance is d upon 2. So that will be G m1 m2 upon d square divided by 4. But now how to solve it out? Denominator for denominator becomes the numerator. So F dash, that is new force, is equals to this denominator will becoming the numerator. So it will be 4 capital G m1 m2 upon d square. And this capital G m1 m2 upon d square is the value of original force, that is represented by F. So new force will be 4 times the original force. If you want, you can take a screenshot. I'll just shift aside. After doing this question, we'll move on to question number 6 because that is also based on the same formula and that is also a similar question only. Okay. So instead of moving to question number 2, we are moving to question number 6 directly. Just let's have a look at the question. What happens to the force between two objects if mass of one of the object is made double? Okay. So one of the masses, say m1, is made 2m1. Then what will be the new force that they are asking you? So m1 dash is equals to 2 times of m1. Right? One of the masses is made double. So new force F dash is equals to capital G. Now instead of m1, what I'm going to write? 2 times of m1 into m2 remains the same upon d square remains the same. Distance between the two is same. F dash is equals to 2 times of G m1 m2 upon d square, and G m1 m2 upon d square could be written as F. That was original force. So the new force is 2 times the original force. Quickly take a screenshot if you want. That is the first part of question number 6. Now moving on to second part of question number 6. The distance between the two objects is double. Distance between them is double. So new distance d dash is equals to 2 times of d. Then you have to find out the new force. So F dash is equals to capital G m1 m2 upon distance square. Distance is d dash square and the value of d dash is 2d, 2 times of d. That is equal to capital G m1 m2 upon 4d square. And so new force is equals to original force. G m1 m2 upon d square is the value of original force divided by 4. Okay. You can take a screenshot of the second part as well. Now, in the second part, they are asking you 2 parts of that. What if the distance between them is double? We have already worked out. What if the distance between them is triple? So instead of 2, now it is 3 times. So it's not a big problem because instead of 2, wherever it's 2, you have to write this 3. So square of 3 will become 9 and the new force will be original force divided by 9. That is 1/9 of the original force. Okay. So whatever is the distance, if it is distance is made 6 times, then what will be the force? Force will become F upon 36, the square of that particular number. Okay, very easy question. Third part, I'm leaving it for you all. Just do it by yourself and let me know your answer in the comment section. If you have any doubt in third part as well, then I'll be just telling you the answer of that also. But try to do that by yourself. It's very easy. Okay. Now, question number 2. Gravitational force acts on all objects in proportion to their masses. Why then a heavier object not fall faster than a light object? Okay. Now, you all know that the acceleration due to gravity is independent of the mass of the object. Acceleration due to gravity is capital G, mass of the earth or mass of any planet on which that we are doing that, and radius of the earth square. Okay. So, this acceleration produced in any object is independent of the mass of the object. So, what will happen that the two objects, whether one of them is lighter, other one is heavier, both of them should fall to the ground at the same time, because this acceleration due to gravity, the increase in their velocity, will not be dependent on their masses. Okay. In this question, we are considering that there is no air resistance. Air resistance is 0. Air is not pushing it upwards. So, the two objects will be coming to the ground at the same time. But just now itself, we'll have a question, we have a look at question number 11 also. Okay, just consider that question. It's just opposite of this one. Okay, let's have a look at question number 11. Why will a sheet of paper fall slower than that is crumpled into a ball? Okay, we have a sheet of paper. If we make it fall from the top of a certain height or a building, and we also have another paper in which we are crumpling into a ball. We are just turning it into a ball. Then we are making it fall from that same height. Then why it's written that why is it that paper falls later on and the ball one comes earlier? The ball will come earlier, and practically that only is happening because of air resistance and because of buoyant force applied on the paper will be more. Question number 11, the buoyant force applied on the paper will be more as compared to that on the crumpled ball. And so that the paper will be coming to the ground later on as compared to the sheet of paper that has been crumpled into a ball. Okay, so in this question number 2, we are neglecting the air resistance. We are neglecting that the air is pushing the lighter object in the upward direction more. But in 11th question, we are taking a practical situation, that practically what is happening. Okay, what is the magnitude of gravitational force between Earth and 1 kg object? So mass of the Earth is given and the mass of other object is 1 kg. And it's given, the radius of the Earth is also given. So what we'll do, put the values. Capital G is 6.67, that will be written as 6.7 into 10 to the power minus 11 into mass of the Earth is given 6 into 10 to the power 24 upon radius of the Earth is given 6.4 into 10 to the power 6. That has to be made a square, and mass of the second object is 1. Now, do you think you need to calculate that? You need to do the calculations? No, you need not do the calculations. Why? Because GME upon radius of the Earth square, that is the same value as small g. You can just multiply the mass of the second object with small g value and you will get the answer. So the answer will be, that is 9.8 and its force. So the answer will be in newtons. Okay. Even if the mass of the second object was not 1, it was 2, then just multiply it with 2. If it is 6, then multiply it with 6. Okay. So no need to find out the answer for this part of the question. Okay. I'll just shift aside. You can take a screenshot. Now moving on to question number 4. Earth and moon are attracted to each other by a gravitational force. Does the Earth attract the moon with a force that is greater or smaller or same as the force with which the moon attracts the Earth, and why? According to Newton's third law of motion, every action has an equal and opposite reaction. So when the force is applied by the Earth on the moon, same force is applied by the moon on the Earth. So both the forces are equal to each other. So whatever is the force applied by the Earth on the moon, same amount of force is applied by the moon on the Earth as well. Okay, so both the forces are equal according to Newton's third law of motion. Every action has an equal and opposite reaction. Okay, now the next question is also based on this one only. If the moon attracts the Earth, why does the Earth not move towards the moon? Why is it not that the Earth is not moving towards the moon? Now, the two forces are same. So, mass into acceleration of Earth will be equal to mass of moon multiplied by acceleration due to gravity of moon. Okay. So, acceleration due to gravity ki jagah, acceleration produced on the Earth will be taken here. Mass of the Earth multiplied by acceleration that will be caused on the Earth. The velocity with which the Earth will be pulled towards the moon. That will be equal to mass of the moon multiplied by acceleration of the moon. Force is equals to mass into acceleration. Okay. Since the mass of the Earth is much more as compared to mass of moon, so this acceleration with which the moon will be coming towards Earth is less as compared to that of Earth. Okay. जिसका मास ज्यादा होगा उसका एक्सेलरेशन कम होगा क्योंकि मल्टीप्लिकेशन का आंसर दोनों का सेम है. Okay. Suppose this one is 50 kg. Mass of Earth is suppose 50 kg. Then the acceleration is suppose 1. And here mass is just 1. So the acceleration will be 50. Okay. The mass of moon is too small as compared to that of Earth. and so we do not find a considerable acceleration of the earth, and so the earth is not pulled towards the moon. Okay, one more question could be there based on that. If earth is attracting the moon, then why doesn't the moon falls towards earth? Earth पे क्यों नहीं गिर जाता moon? At every point of time, whenever an object is moving in uniform circular motion, its velocity, the velocity of the moon, is keeping it away from falling towards the earth. If the moon stops rotating, if the moon stops moving in the uniform circular motion, if its velocity becomes zero, then definitely the moon will fall on the earth. Okay, very dangerous situation. Okay, but don't worry, that won't happen. So the velocity of the moon is keeping it in the outward motion. That is why it is not falling towards the earth. It's in the same way that you can tie a ball and move in a circular motion. Okay, so its velocity is just preventing it from falling towards the earth. Okay, question number 5 is clear to everyone. Now, question number 7 we are not going to consider. We have already seen that in the theory portion. Question number 8. What is the acceleration of free fall? Acceleration of free fall is the acceleration due to gravity. So, acceleration of free fall is the acceleration due to gravity. It's the same. Now, question number 9 is also very easy. What do we call the gravitational force between the earth and an object? The gravitational force between earth and an object is known as weight. Remember, the definition of weight was the force with which the earth attracts any object towards itself. Okay, so the answer for question number 9 is weight. Now, question number 10 also, we have discussed that in the previous video itself. Question number 12, coming to question number 12 now. 11 we have already discussed right now. Gravitational force on the surface of moon is just 1/6 as strong as the gravitational force of earth. What is the weight in newtons of a 10 kg object? 10 kg is the mass of the object. So, mass of the object is 10 kg. What will be the weight of the object on earth? So, weight of the object on earth will be mass into acceleration due to gravity on earth. Acceleration due to gravity on earth is 9.8. So, it will be 98 Newton. So, weight on earth will be 98 Newton. Now, what will be the weight of that person on moon? That will be 1/6 of the weight on earth. So, 1/6 of the weight on earth, because acceleration due to gravity on moon is 1/6. Okay, 16.33 Newton. Fine. You can take a screenshot if you want. So you can see. Now question number 13. Now comes the real numericals from the chapter. But for doing the numericals, we will be using the 3 equations of motion. So I'll be writing the equations of motion also on one side of the board. First equation of motion is V is equals to U plus AT. Instead of A, here we'll be using G, the acceleration due to gravity. Second equation of motion is S is equals to UT plus half AT square. Instead of S, we'll be using height. And instead of A, we'll be using small g, that is acceleration due to gravity. Last one is V square is equals to U square plus 2AS. Here also, instead of A, we'll be using small g, and instead of S, it will be replaced by H, height. Okay. Now, question number 13, we'll be solving that out. A ball is thrown vertically upwards with a velocity of 49 meter per second. Initial velocity of the ball is given 49 meter per second. Calculate the maximum height up to which it is going to rise up, and the total time to return to the ground, to the surface of the earth. So you'll have to calculate the time taken by the ball to reach the highest position and multiply it with 2. Okay, let's see. The first question is to calculate the height to which it rises. You have to find out the height. Okay, nothing else is given. Acceleration due to gravity, you already remember, and final velocity will be 0. Why 0? Because whenever you throw something in the upward direction, it reaches its maximum height where its final velocity becomes 0. And then again it starts coming back to the ground, and its velocity, like, it goes on increasing, and it's coming towards the ground. So when an object is thrown upward, its velocity continuously decreases till the point it becomes 0. And once it becomes 0, it starts coming back to the ground. So here the final velocity will be taken as 0. Okay. Now you have to find out the height. Height could be found out by using second or third equation. But how to find out which equation to use in this question? Remember one trick. जब भी time नहीं हो, use the third equation. Whenever you don't have time, means whenever time is not given in the question, use the third equation of motion. Okay. So third equation of motion says V square is equals to U square plus 2AS. Now, since the object is going against gravity, we will be using v square is equals to u square minus 2gh. Why minus? Because acceleration due to gravity will be negative, because its velocity is continuously decreasing as it's going against gravity. Fine? So it's taken as negative. Now putting the values, v0, initial velocity was 49 square minus 2 into. Now what to take the acceleration due to gravity? Whenever it's not mentioned in the question, you can take the value of small g as 10 or 9.8. Both are correct. But in this question, remember two things. Whenever such values are there like 49 or 19.6 or 196, these two values, if they are there in the question, then remember to take the value of small g as 9.8. That will make your calculations very easy. Because 49 is half of 98 and 196 is 2 times of 98. ठीक है, तो आपकी कैलकुलेशंस इजी करने तो रिमेंबर 49, 196 ऐसी कुछ वैल्यूज हैं, then take the value of small g as 9.8. Okay, so small g will be taken as 9.8 into height. Fine, it's all negative, that will go that side to make 2 into 9.8 into height is equals to 49 into 49. Height will be equal to 49 times 49, and cross multiplying that will come down 2 into 98. I want to remove the decimal, so I'll divide it by 10 and denominator for denominator becomes a numerator. If you don't want to make the changes here, even here you can just divide it by 10 to remove this decimal. Okay, so cross multiply करेंगे तो these two will come down and this 10 will be going up there. Fine, anyway you can do that. Now 2 times 5 is 10, 49 divided 2 times is 98. Now 122.5 meters. Okay, 49 times 5 and then divided by 2, you will get the answer as 122.5 meters. This is the maximum height reached by the stone. You can take a screenshot and then we'll do the second part of the question. You are asked to calculate the time. So we'll use the first equation of motion or second one. Any of the two could be used. Okay, so v is equals to u plus at. So here v is equals to u minus gt because it's going against gravity. So v is 0, u is 49 minus 9.8 into t. That will be there. It's minus. We'll shift it to the opposite side so that it will become positive. 9.8 t is equals to 49. I want to remove the decimal, so I will divide it by 10. Now leave the t here. We have to find it out. So 49, just cross multiplying that, 10 will go here and 98 will come down. 49 2 times, 2 5 times. So the time comes out to be 5 seconds. But is that your answer? No. Because it will be taking 5 seconds to move upwards and the same time will be taken by it to come back to the ground. So the total time taken is equals to 5 plus 5, that is 10 seconds. I'll just shift aside. You can take a screenshot of this question as well. So it will be coming back to the ground in 10 seconds. Now coming to the next question, number 14. A stone is released from the top of a tower of height 19.6 meters. I told you 19.6. Whenever 19.6 or 49 is there, then you have to use the small g value as 9.8. That will make your calculations easier. A stone is released from the top of a tower of height 19.6 meter. So height is given 19.6 meters. Calculate its final velocity just before it touches the ground. We have to calculate the final velocity. Whenever we are dropping something, means the initial velocity will be taken as 0. When you drop something, then initially you are not providing it any velocity. You're just letting it come down under the effect of gravity, under the force of gravity. So the u, small u, that is initial velocity, which is shown, it's taken as 0. Okay. Now I told you, whenever you don't have time, take the third equation of motion. जब भी question में time given नहीं हो, then use the third equation of motion. So here you have to calculate the final velocity. So v square is equals to u square plus 2as. So in this question it will be v square is equals to u square plus 2gh. Why positive? Because it's coming towards the gravity. Okay, so gravity will be taken as positive. V square you have to calculate, u square is 0 plus 2 into 9.8 into height is 19.6. So v square becomes 2 into 9.8 is 19.6 and 19.6 of the question as well. So v is equals to under root of this, that will become 19.6 meters. Seems as if the calculations are difficult, but they are very, very easy only. Okay, so I hope you have taken a screenshot. Now question number 15. A stone is thrown vertically upwards with an initial velocity of 40 meters per second. Take the value of g as 10 meters per second square and find the maximum height reached by the stone. you have to find out the height reached by the stone. When it's thrown upwards, the final velocity is going to be 0. Okay, so you have to find out the height. Whenever you don't have time, use the third equation of motion. So v square is equals to u square minus 2gh. Directly I'm using minus 2gh because now you know it's going against gravity, so it will be minus 2gh. Okay, now v is 0. 0 ka square also it's 0 only. U square is square of 40 minus 2 into 10 into height. Small g value is given as 10 in the question itself. This is negative. We'll move it to that side. So it's 20h is equals to 40 into 40. So height is equals to 40 into 40 divided by 20. 22 times is 40. 40 into 2 is 80 meters. Very, very easy question. Okay. Now, is that all asked in the question? No. What is the next displacement and a total distance covered by the stone? So the stone is going to rise high and it's going to come back again to the ground. So when it's coming to the same position only, the total displacement is going to be 0. And total distance covered will be, it will be rising up 80 meters and coming back to the ground 80 meters. So it will make a total of 160 meters. And displacement is going to be 0 because you just need to remember that displacement is the change in the position. How much its position is changed from its original position. So it came back to its original position. So displacement is going to be 0. You can take a screenshot if you want. Now coming to question number 16. Calculate the force of gravitation between Earth and Sun. Okay. For Earth and Sun, how much is the gravitational pull? Let's see that. So you have to calculate the gravitational force of attraction between Earth and Sun. So formula will be capital G, mass of the Earth, mass of the Sun upon distance between the two ka square. Putting the values. The value of capital G is constant. It's 6.67. I'm just taking it 6.6 into 10 to the power minus 11. Mass of the Earth is given into 10 to the power 24. Mass of the Sun is given 2 into 10 to the power 30 upon distance between the two is given as 1.5 into 10 to the power 11. 1.5 into 10 to the power 11. It's a square, so we have to write it again. Okay, these are the values given in the question. Now we just need to do the calculations. These calculations look to be difficult, but actually they are not difficult. We just do it. 1.5 is here and here it's 6. So I would like to remove the decimal by making it 60. Is that fine for everyone? I have removed the decimal from 1.5. Then it will become 1.5 divided by 10 and denominator for denominator becomes a numerator. So there is 6 tha, usko 60 bana diya by multiplying with 10. Fine? Because I know that 15 4 times is 60. Okay? Now, here is one decimal and here also at one place it's decimal. So I can remove the decimals. Okay? Now, dividing it. 66 divided by 15. 15 4 times is 60. Remainder is 6. Point. Then again we get a 0. So 15 4 times is 60. Okay? So 15 4.4 times will be 6.6. Okay? I'll just remove these calculations. Fine? Now, denominator is all cancelled out. Now just we'll get 4.4 into 4 times 2 is 8. I'll be writing here as 8 into 10 to the power. 24 and 30 are there. When the exponents are there, then we just add them. Both are positive, then we are going to add them. Why we add them? Suppose you have 10 to the power 2 multiplied by 10 to the power 2. You add them and you get 10 to the power 4. Why we do it? Suppose you don't know that, I'm explaining that. 10 to the power 2 means 100 multiplied by 10 to the power 2 means again 100. Okay? So the answer will be 1 and 1, 2, 3, 4 zeros. So that's what we have written. Okay? So whenever you have both the exponents as positive, you add them. And if one of the exponents is negative, we subtract that. Okay? So let's add that. 24 plus 30 gets 54 into 10 to the power minus 11 is there. And here 10 to the power 11 and 10 to the power 11, it will become 10 to the power 22. Now this 10 to the power 22, when it will go up, or we can do 10 to the power 54 is there, divided by 10 to the power 22. So when we have to divide, like 4 zeros are there and you have to divide it by 1 or 2 zeros, then you just cancel them out. Okay, you subtract the number of zeros. So here also it's the same logic. 10 to the power 54 minus 22. Okay, what will be the 10 to the power 54 minus 22? It will make it 32. Okay, and 10 to the power 32 minus 11 is there, so it will make it 10 to the power 21. Fine. I hope you are clear with how to solve exponents. So 10 to the power 21. So it comes out to be 10 to the power 21 into 8 4s are 32, 3 carry up, 8 4 32, 33, 34, 35.2. That could be written as 3.52 into 10 to the power 22. If you are getting confused at how to solve exponents, you can even leave your answer like this only, that force is equal to 35.2 into 10 to the power 21 newtons. But the standard form of expressing the decimals is like this, 3.52 into 10 to the power 22 newtons. Okay. Even if there is slight change as compared to the answer given at the back of your book, they might be doing it with taking the value of capital G as 6.7. But I have taken at 6.6 for making the calculations easier. Okay. But never mind, still 3.5 is the same as that in your book. So even if some point like a difference is getting there in your answer, you need not worry about it. That is neglected because it's 10 to the power 22 is the same only. Okay. So you can take a screenshot. I'll shift to side. Now moving on to question number 17. A stone is allowed to fall from the top of a tower 100 meter high. One of the stone is coming down and the height of the tower is 100 meters. And at the same time, another stone is projected vertically upwards with the initial velocity of the second stone as 25 meter per second. Calculate when and where the two stones will meet each other. Okay. Suppose they meet at this point. Okay. And the distance covered by the first stone is x. Then what would be the distance covered by the second stone? It would be 100 minus x. Okay. Total distance is 100. अगर ऊपर वाला stone कितना नीचे आया है? X distance आया है. तो नीचे वाला stone ऊपर कितना गया होगा? That would be 100 minus x. Is that fine for everyone? Okay. What is the initial velocity of the first stone? That is 0. And second stone, it's 25 meter per second. It's given the question. Okay. Whenever you are dropping something, the initial velocity is 0 only. So the first stone's initial velocity will be taken as 0. Now, we'll use the second equation of motion because we have to find out this x. Okay. So, using the second equation motion, we know that S is equals to ut plus half at square. So, for the first stone, like it in x, the distance is x. है ना? जितना distance first stone ने cover किया, that we have supposed to be x is equals to initial velocity is 0. So, anything multiplied by 0 is 0 only. Plus, why plus? Because it's coming towards gravity. So, acceleration due to gravity will be taken as positive. Plus half into a. The value of acceleration due to gravity will take as 10. And t square will remain t square only because we don't know the time. Okay. Now, we get x is equals to 5t square. That we have got equation number 1. Okay. So, x is equals to 5t square. Fine. Now, for the second stone, this is for first stone. Now, for second stone. For the second stone, what will be the values that we'll be taking? Initial velocity is given 25 meter per second square, meter per second. Okay. Suppose the distance covered, we'll use the same equation. S is equals to ut plus half at square. But instead of plus, we have to take it as minus half gt square because it's going against gravity. Okay. So, x is, what is the distance covered by the second stone? 100 minus x. Fine, everyone? That is equal to, initial velocity is 25 into t. We don't know the value of t. But why we have taken the t? Because जितना time ऊपर वाला stone नीचे आने में लेगा, उतना ही time नीचे वाला stone ऊपर जाने में लेगा. Okay? So, the time taken by the two stones is same. So, we are taking the value of time as t. Minus half g is 10 t square. Okay. So, we get 100 minus x is equals to 25t minus 5t square. 2 divided by 10 is 5. Okay. We'll just take the value of x only. Here also we are going to find the value of x. So, in two equations, we'll be getting the value of x. Then we can compare both of them. So, from this equation, I just want to move the x that side. So, here it's negative. It will become positive. So, I'm shifting x towards the right side. And whatever is on the right side, that I'm shifting towards the left. So, it becomes 100 minus 25t plus 5t square. I hope this much is clear to everyone. What we have done here, x was negative here, I shifted it to the right side so it becomes positive. And here whatever was there, I have taken it to the left side. So both of their signs will be changed. Okay. This is also the value of x. This is the value of x. So from equation 1 and 2, we get x is equals to this and x also equal to this. So these two are equal to each other. So we get from equation 1 and 2, we get 5t square is equals to 100 minus 25t plus 5t square. Agree with me? This and this are same, so that could be cancelled out. This minus 25t is negative here. I want to move it to the opposite side, so it becomes positive. So 25t is equals to 100. So t equals to 100 upon 25 and that it make way 4. So after how much time the two stones are going to meet each other? That is 4 seconds. Okay. So the two stones are going to meet each other after 4 seconds. And where they are going to meet each other? Let's see. X. Find out the value of x. So x we know that it's 5t square. So 5 into, what's the value of t? 4. 4 ka square. It's 5 into 16 and that will make it 80 meters. So x is 80 meters. So the two stones are going to meet each other at a distance of 80 meters from the top. Okay. If you wanted to find the distance from the ground, just subtract it from 100 and you will get 20 meters from the ground. Both the ways the answer is correct. You can write 20 meters from the ground or 80 meters from the top, but you have to specify from which position you are explaining your answer. Okay. So you can take a screenshot. I'll shift to side. Now coming to question number 18. A ball is thrown vertically upwards, returns to the thrower after 6 seconds. It's thrown upwards and it comes back after 6 seconds. Since it's coming back after 6 seconds means it's taking 3 seconds to move up and 3 seconds to come back. 3 plus 3 it makes 6. Okay, since it's taking total 6 seconds means 3 seconds to go up and 3 seconds to come down back. The velocity with which it was thrown upward, you have to calculate the initial velocity. Here when it's thrown upward, the final velocity is going to be 0. So let's find out the initial velocity. We need to use the first equation of motion. V is equals to u plus at. So final velocity is given 0. Initial velocity you have to find out. You can take the value of acceleration due to gravity as 10. But it's going against gravity, so it should be taken minus 10. T is given as 3 seconds. Okay, it's negative, so we'll move it to the opposite side. So it's 30 is equals to u. So u is equals to 30 meter per second. Don't forget to write the unit. Otherwise, your marks will be deducted in the exams. So it's 30 meter per second. Now, B part is maximum height it reaches. What is the height reached by the stone? For doing the second part, you can either use the third equation or the second one, whichever you feel more good. Okay, so I would prefer here to use the second equation of motion. H is equals to ut minus half gt square. Okay, now h is equals to initial velocity is 30, time is 3 minus half into 10 into t is 3 ka square 9. It's 90 minus 45. That will come out to be 45 meters. So the maximum height reached by the stone will be 45 meters. The second part also we have done. You can take the screenshot of the two parts so that we can move on to the third part by raising these two. Its position after 4 seconds. It's asking you that after 4 seconds, where is the stone? At what height is the stone? Okay. So for 3 seconds, it was moving up. After 3 seconds, it started moving down. So when it's coming down, how much time it has moved down? Out of 4, subtract 3, that is 1 second. So after 1 second, what is the position when it's coming down? That we have to calculate. So we can take the time as 1 second. Okay. So the time that will be taken to calculate the third part will be taken as 1 second. Okay. Now when it's coming down, the initial velocity is 0. Time is 1 second and you have to calculate the distance covered. Okay. So we can take S is equals to ut plus half gt square. Why positive? Because it's coming down. Initial velocity will be 0 because at the topmost position when it started falling back, its initial velocity at that point became 0 and then it started coming back to the ground. Ut is 0 plus half g is 10 into t is 1. Square of 1 is 1 only. So s becomes 5 meters. So at what is the position of the stone? That is 5 meters from the top, or you can write the total height was 45 meters. So the current position of the stone is 45 minus 5, that is 40 meters. Position of the stone is equals to total height minus the distance covered by the stone, that is 5 meters. So it comes out to be 40 meters from the ground, or you can say 5 meters from the top position. Okay. Any of the two ways you can express your answer. Again, I'm shifting to side so you can take a screenshot. Okay. Now just two questions left. They are both theory questions only. In what direction does the buoyant force of an object immersed in liquid acts? The buoyant force always acts in the upward direction. It tries to push the things out of water. Okay. Question number 20. Why does a block of plastic released underwater come up to the surface of water? It's because of the fact that the buoyant force is more than its weight. The weight of the plastic block is less as compared to the buoyant force acting on it, as compared to the water displaced by it. Then the block is going to come back up. Okay. One more question is there based on the same concept of buoyant force. Why does ice floats on water? Ice floats on water because ice has some air molecules trapped in it. So the air molecules makes that density of ice to be less than that of water. And so it rises up and it floats on water. Okay. So I hope you are clear with the concepts of gravitation chapter. I hope I have been able to clear up your doubts. Do let me know anything next you want to see from me, and just keep on studying and score well. That's all for today. Good day, everyone.